Hello guys. Welcome back to learning Algebra 1 with me. Today we'll be continuing in chapter 1 and we'll be introducing some new concepts by using the old concepts that we learned in lesson 1.1 of this whole journey in chapter 1. So, our topic's name today is solving multi-step equations. So let's dive in. Okay. So our main focus today is what we all will learn today is how to solve multi-step linear equations using inverse operations. So you might heard of the word inverse. Well, inverse is like the opposite of something. Okay. So it's like when you put something in, you get it. So it's like an input and you get like an output. So it's like always saying you're putting something in and you're getting a different solution sometimes. Alright? So that's how inverse works. So we'll be also talking about using multi-step linear equations to solve real life problems. Okay? And yeah, using unit analysis to model real life problems. Okay? So solving multi-step linear equations. So our core concept on this is basically to solve the multi-step equation, right? You need to simplify each side of the equation if necessary, and then use inverse operations to isolate the variable. So remember how I talked about isolating the variable last video or last lesson? Well, we're implementing that again. It's just you just don't have one step. It's like not just like adding or subtracting and then you doing that on the other side too and then dividing it. It's always not like that. It always is like you just have to give the variable a, a specific value that it wants, and that's all the questions is based on. So basically we can it means it's just not like multi-step, meaning there's two or three steps. There's just not one. Okay, like the last lesson we did one or two steps. Today it's gonna be two, maybe three, maybe four. Sometimes there are more than that also, but for today I think it's only two or three, max. So our first question is actually solving with this two-step equation. Okay, so it's gonna take two steps to get your answer. Well, I mean, you already see the answer, but I'm gonna go through it with you. Alright? Let me just move this a little down for our space. So, what we're actually doing, let's say the small one today. So we have 2.5x minus 13 equals 2. Okay? And we have, so what we're gonna do, what we learned last class, this is a problem like last class, remember? We did something um, something giving a value of x like 5x plus 4 equals 29. We did something like that. That's just an example. We didn't do that exact problem, but it was you do the minus 4 because you want to get rid of the 4 and isolate the variable. And if you do minus 4, then you do that on the other side. You get that 5x equals 25. X equals 5. So that's basically what this question is. It's what we did last class. We're just doing that again. This is just one practice problem. I know you can see this problem. This is what I'm talking about, 3 to 4 steps, maybe even two. But I mean, this is more like a two-step. This one right here is more like a two-step. So yeah. Okay, let's go with the two-step first, and then we can move on. So what we're gonna do is again isolating the variable. That's our main point, to give the variable a value. In our case right now it's x. So what we have to do is plus 13 on both sides because we want to get that to equal 0, or just isolating it, and plus 13 on this side. make the line if you want. I just like to do it. 2.5x equals 15 x equals 2. So that would equal to 6. So yeah, we isolate the variable first, right? That's our goal. Give it a value. So what we did is plus 13 on both sides, as we learned in the addition property of equality last class, or any property of equality. Property of equality is just like having two sides, or doing whatever you're doing at one side, doing it to the other. So like all those properties of equality we talked about last class that's how it is. That's property of equality. It's also easier to remember because it's equality. That's like the term used for equal. So that means you can say, if you don't remember what it means, then you can always remember by using or knowing the word equality, knowing the meaning of it. But yeah, so x equals to 6. And like always, you could put it back in. So you could do, again, like you could check your answer if you want to see if it's correct. So you could do 2.5 times 6 minus 13 equals 2. 2.5 times 6 is obviously, we just did that, 15. You can also use a calculator if you want. But I would say just do it on a piece of paper, because it then gets registered in your mind. So that, bring that 13 on this side, so we do that plus 13. I'm just not going to show it to you right now, but that's what I'm trying to do. So 15 equals 15. So that's correct. You know what? I'll just move this a little down for our space. And I'll have to move. Ooh, so it's in the middle. Ooh. Yeah, okay, what just happened? Oh my god. I'll just move this down when we get to it. But yeah. Okay. Now, moving on. Oh, where am I? Yeah, over here. So now what we're going to do is, this is called as combining like term, not the other one that we just did, but the next one I'm going to show you, example 2, is combining like terms to solve an equation, okay? So what you're going to do is, we're going to solve this problem together. It might be difficult, it might not be difficult, okay? We're going to do this together and try to do it, okay? So we haven't written out. Let's write it out first. So it says minus 12, or negative 12, equals 9x minus 6x plus 15. Looking at this, you might feel it's confusing because now you have two x's, right? But what combined like terms means? So it means just like saying, like, if you have, I'll give you an example, but if you say 12 plus 10, that literally means combining like terms. I'm not even kidding. That literally just means combining like terms. Like terms are like numbers, or certain values, or like certain numbers you can add together. Not even certain. It's just like you're adding the number who has that type of like property with it, or the same identity, or it's classified as the same identity. So 12 and 10 are basically numbers, okay, which you can add together, right? But if I were to give you 12 plus 10x, you can't add that together, because until and unless you don't know the x value, then you cannot add that up, because there are not like terms. One is a number, which is 12, and 10x is a number with a variable with it, okay? So you cannot add up. So that's what the combined like term says. You can only add up numbers which are classified as their identity. So like I said, 12 plus 10 will be combining like terms, but 12 plus 10x is not combining like terms. So remember that. So, you know what? I'll just make an x. Now I'll just show it. I'll just write it down for you. Oh, let me make that in green actually, so it's easier to understand. Okay. Now if we go and look ahead for this problem, okay? So we just wrote out the equation right now, okay? So now what we're gonna do is, what do you see as a combined like term? What can you combine, and what are the like terms? So you see 9x is to 6x, and 15 is to negative 12, right? You see that? So what we're going to do is, and I'm actually going to do them in different colors for you to understand. What we're going to do is, so first we do negative 15 because that's what you do, isolating the variable, right? That's our basic goal first, right? So that gets us negative 27 equals, let me just change the color. Is it too dark? I think that's too dark. Yeah, this one's better. Yeah, and then we have 9x minus 6x. Okay? Now what do you do? So what you do now is that, like I said, 10x cannot be added to 12 until x is given a value and you multiply with the 10 and then you add up. So if you were to get like 6 as the x value, then you would do 12 plus 10 times 6, which is 12 plus 60, which is 72. Then you can say you have combined like terms. But until and unless you have an x or variable which has not been defined or given a value, you cannot add it with a normal number. Okay? Just to remember that. I keep implementing it because people make mistakes. I've also made mistakes, okay? So it can happen, okay? So it is a little confusing sometimes, but as we go towards it and doing more questions like that, then you know how to not confuse yourself or just mess up. I'm just gonna work out my camera a little. Yeah, that looks better. Alright. So now we have negative 27. Oh, first I forgot to tell you how to do it. Sorry. So since we have 9x and 6x, okay, we have 9x and minus 6x, you basically just don't focus on the x because you know that if a 9x minus a 6x is just doing 9 minus 6 because x and x are like terms, they're the same variable. But, for example, not to confuse again, but what would happen if I changed this to y? You cannot add them up because they're different variables. So you cannot do 9 minus 6. But since they're the same variable, then you can subtract, add, whatever you want to do. Multiply even, does not matter. So what you're going to do now is negative 27 equals what? You're just going to do 9 minus 6. Alright, you're just going to do 9 minus 6. Think it as in you're combining like terms. Like x is a like term with 9x is a like term with 6x. Okay? Because they have the same variable. So what you just do now, if you know that there's the same variable or they're like terms, then you just do normal addition, subtraction, multiplication, division. But you just do to see if they're like terms or not. So now since I know that 9x and 6x are like terms, I have to do what the operation says, the sign says. So that means it's saying to subtract 6x from 9x, which is just going to give you 3x. Now we just do our normal division. We isolate the x by dividing 3 on both sides. And then x equals to negative 9, because negative 27 divided by 3 equals to negative 9. So, yeah. And that's equal to, so x is given a value of now. After finding and proving it, you know it's negative 9. So now we're going to do some problems. Okay, we're going to do some extra, like three problems. Yeah, three problems to just monitor how you guys are doing, just to know. Okay, so I will give you time until, let me see, until I write all of these down. Okay, so the clock is starting. You have, you can solve, you can pause the video even, I don't care, but just try to solve them on your own first. Then, if you are struggling, then you unpause the video and look at how I did it, okay? So I'm just gonna write it down. You can pause the video now if you want. Might be a great time. You have time until I write these down also. Just to let you know. I'm writing it too small, but it's okay. I think number one you guys can do easily because that's what we discussed last class. Maybe even number two, but number three, yes. It's like the one that we just did, combining like terms. But it's okay. It's not that hard. I'm trying to not give you hard ones, you know? It's easier if you do the easy ones first and then you start getting complicated. Okay, so I'm ready actually. And you know what? It's okay, you know what? Actually, let's just make this one whole bigger. Because I feel I've taken too small. Okay. Well, you have an extra like 5-10 seconds to do some more of them, you know? Alright. Now, if you have like pause the video, you can unpause it and then look how it did it. So for number one, what you do first is like the one that we did, the first one for today, or like the ones that we did like last class. You have to just focus on isolating a variable, right? So what you're gonna do is -3 on both sides, right? That's how the subtraction of property of equality says. If you subtract from one side, you have to subtract from the other to make that equation equal, right? So you cancel that out, okay? So now you have 2n equals -12. So n, oh, actually, let me divide it for you so it's easier. It means, so n would equal to 6. Yeah. Okay. So that one I just went through a little faster because we already know how to solve it from today, the first one that we did, and from last class. So I just wanted to go over that, quicker so we could get like, more problems in for today. Alright. So what we're gonna do is actually now we're gonna do number two. I know it's surprising when I say it, but yeah, we're gonna do number two. Okay, so number two is -21 equals 1/2, actually half C. I always say 1/2, but it's actually half C minus 11. Okay, so what you want to do in this one is that you see half C as a variable or like a number in the variable. So we're gonna isolate half C. You see, I mess up every single time. It's okay. Half C is gonna be the thing which is gonna be isolated, right? So what we're gonna do is plus 11 on both sides, as the addition property of equality says. Cancel this out. This equals. So this is -10. Is it? Yeah, it is. You and I forget sometimes. So, first of all, you can't divide a fraction by a fraction, okay? You can't do that. So, what you're going to do is, you might have learned this in pre-algebra also, or like 5th grade, 4th grade, okay? But what you have to do is take the reciprocal. So, you do 2 over 1. And since you took the reciprocal over here and multiplied it, you're going to do 2 over 1 here too. So what you get is 2 over 1, or you can, I would say always write the reciprocal, but when you do it in your head, okay, You can solve it whatever you want. Now in this one, it's 2/1. Sometimes it could be like 2/6. So that's why I would say like always just like first you know how to multiply a fraction. You do the top or the numerator, and then whatever you get as your that as your numerator, the new numerator, then you divide it by the denominator. Okay, so what you're gonna do over here is 2 times -10 is -20, divided by 1 is -20. -20 equals. Now in this case, look at this. 1/2 times 2 times 1 is what? So that's gonna be 1 times 2 is 2, right? And then 2 times 1 is 2. So 2/2 equals 1. So that equals 1c, okay? Or just say c, okay? So your answer is for c, or giving the value of c, or finding the value of c, is -20. Alright? So this one's mixing number 1 and a little part of today's lesson. Okay, like 2 or 3 more steps, 1 or 2 more steps than what we did from last class and like the first problem today. So now what we're gonna do is number 3. Number 3 is the same format of how we did this one. -12 equals 9x minus 6, x plus 15. Alright, so in this one, what you do is first you just want to isolate the like terms by itself. So what do you see as a like term? You see -2x and -10x. Just mark that and mark that. And you see 12 and 18. You want to bring each other to equal to each other, so it's easier for you to understand. So what we're going to do is -12 on both sides to isolate the variables, and -12 on this side. Okay. Then we have -2x, -10x equals 18 minus 12. I didn't subtract it yet because I wanted to like do an extra step instead of subtracting, because I want to add them or subtract them together. So now, since you know x and -2x and -10x are like terms, now you can just do what the sign says. So -2, -10 equals -12, and the like term sign is for the variable is x, and this is 18 minus 12. That's simple, 6. Now you just have to divide like a normal thing. -12, both sides. Cross that out, -12. X equals to -1. Half. See, I'm gonna say 1/2. I always say 1/2 so much, but it's actually wrong. So don't do the mistake I do. Just say half. It's hard to get in my brain function memory. So it's gonna be equal to -1. See, I'm gonna say it again and again, but I just can't put it in my brain. So it's -1/2. See, I got that part right. -1/2. Okay, so x equals to -1/2. Okay, now what we're gonna do is this other problem. Alright, so now we're gonna do the other problems. Now we're actually gonna go back. So this is example 3, okay? And this one is using structure to solve a multi-step equation, okay? This is what it means, okay? So you might see some things from Algebra 1, right? Okay? We're learning Algebra 1. I'm sorry. Pre-algebra, like you see the parentheses, which means what? Yes, you're correct. Distributive property. I hope that you were thinking that, okay? I hope that you were thinking that. So we're just going to write it out first. Okay. Now, what do you do? Tell me. So, what we're going to do is first isolate, or actually, what do you have to do first before isolating? You could actually do either two steps in this. You could do one thing or one thing, but since as teachers or like anyone talks when doing math or something it's called as order of operations, or you can actually say PEMDAS, right? It's PEMDAS, right? Yeah, it's PEMDAS, right? Yeah. So it's called as PEMDAS. What we're gonna do is we're gonna see, well, should be there, but it's like multiplying technically or distributing. So it's gonna be 2 times 1 is 2. 2 times negative x is negative 2. Oh, yeah, negative 2x. Plus 3 equals negative 8. Now you might look, oh my god, I see 2 and 3 on the same side. Well, like we talked about before, 2 and 3 are the same classified as an identity or like from the same category as a number. So you can say that you can add them, you can subtract them, you can multiply them. Actually, what I mean, yeah, you can just add them or subtract them. So in this case, you're adding 2 plus 3. Or what you could do to make it simpler or to know what to do, you can just say you can rearrange the order of this. So you could say negative 2x. And since you know this is technically like plus 2 because it doesn't have a negative to it, so you can just say plus 2. Wait, let me just delete that. Yeah. Plus 2, and then what you know is plus 3 equals negative 8. So now you know that 2 plus 3 is what? 5. So you know that negative 2x plus 5 equals negative 8. Now look at that. That's what we did in the first class. Simple two-step equation. Solving it. So what you're going to do is isolate the variable again. Negative 5 on both sides. Negative 5 on this side too. Equals negative 2x. Small like z. Oh, that's a really bad one. Let me just rewrite that too. Yeah, that looks better. Negative 2x equals negative 13. Divide negative 2 on both sides. X equals 13 over 2 is 6.5. Okay? So, 315. I don't have more. Okay, 6.5. So, you could do another method. So, that was actually our last question for like practicing today. So now I want what you guys want I want you to do is to actually do these questions for practice on your own. These ones I want you just to do on your own. This is gonna be like something like your homework, with addition to a little. Just I'll be a little nice and not give a lot. I want you to do these ones. Okay, that's all I want. That's all I want you guys to do. That's your homework. There's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 problems for homework or just practice. So I want you guys to practice this topic. Let me know how it goes, okay? And I'm gonna help you more through Algebra 1 and make you have a great success in it. I hope you guys have fun learning with me. And remember, my name is Ayaan and I'm from KARMANT Learning. And yeah, please keep liking and subscribe to the videos.